So crucial to make sure we understand why we're doing what we do. Next up are the hypotheses we're going to test. Null and research. Every study has these. Every study has these. The question is, are they always indicated in the title of the study? Not usually. Usually the research hypothesis is indicated if it was a successful study, meaning there was significance found. Caffeine lowers heart rate amongst submaximal exercise loads amongst elite male cyclists. Okay, that's a very strange thing, but that was the research hypothesis. Let's give them coffee and see what happens. Right? Green tea. There's a high correlation between consumption of green tea and lowering breast cancer rates. Okay? Again, that was a significant finding from a study. And you read that in the title. You don't read titles very often, unfortunately, that say things like, oh, we drank a lot of Jolt and people still die from smoking. You don't read stuff like that because it's not newsworthy, because it's not surprising. So you read about these, usually you don't read about these. Now, here's a question, an overriding question. If we're testing this drug, this vaccine, and we want to see that it's working, what's our belief about the drug if it's working? If it's working, what's our belief about that drug?
That it works.
Define. Thank you, Alan. Love that.
It lowers the
That's what I was looking for, that it works. I was going to get you to define the word work, which means that it lowers the flu rate. That it works. So that it lowers the flu rate. And what is the flu rate again? 12% without the vaccine. I'm going to redraw this curve. I don't know why I erased it. I should have left it up there. Okay, there's the flu rate. If we think our flu vaccine is effective, that means the percentage of those who take the vaccine and then get the flu should be what compared to 12%? Statistically significantly not good. Oh. Austin, I want to say what you said, exactly what you said. He said different. Wait, lower.
No overlap.
Well, good, no overlap is implied, but you see, he said different and then he caught himself and said lower. Because couldn't you be statistically significantly different and have the adverse effect of what you want?
Right.
Give people the vaccine and then 85% of them get the flu. Okay, let's sell that to the military as a biological weapon. And I'll retire off the funds, yeah? So that's what I love, the fact that you checked yourself and you said, oh, no, lower. I want this to be a one-sided confidence interval, not a two-sided. A two-sided confidence interval would find the flu rates that are less as well as the flu rates that are better. We don't want this. We want to check the ones that are less, the ones that are lowering it. The beauty of this is you can synopsize that entire statement in symbols. You ready? Here we go. The proportion of those who took the vaccine and then got sick, if the vaccine is working, should be statistically significantly less than 12%. Boom! That's it. That mathematically brings that whole idea together. This is why I have you define your variable up here. Because then you can just read the words, plug them in down here, and be like, oh, I see what that statement means. It means we give the vaccine to a bunch of people. Give the vaccine to a bunch of people. And I want to see if the percentage of those getting sick is less than 12%. When you see the symbol less than in this class, it's immediately applied to have two words before it. And those two words are, and they both start with S, and Blake was picking on them earlier, statistically significantly. That's implied. That is implied in that symbol in this class. So please, you'll often, some of you will correct me from time to time. When you said different, you mean statistically significantly different? I'll be like, hell yeah, I did. But it's implied. It's implied. Just like when we run a confidence interval, it's implied that it's at 95%, unless it's Carly who runs it at 99, it's totally fine. Okay? Good. Good. So this is what we want to believe, yes? We want to believe this, if we're the makers of this drug, of course. If we're making this vaccine and we want to sell this and make people healthy and maybe make some money off of it, I guess, business. We want to believe this, yes? Now, that's called the research hypothesis. That's from last class. I had you guys actually pulling these out of the articles last class. Green tea appears to be associated with lower breast cancer. Caffeine appears to be associated with lower heart rate in submax exercise. Secondhand smoke appears to be connected in some way to lowered lung function. I had you guys writing these out in words. Now we're writing it in symbols, because symbols are easier to test mathematically. Good. What's going to go here? Good. Do you remember the relationship between H naught and H1? Remember what H naught is compared? It's the... Oh, I love the word inverse. It's the null hypothesis. Love it. It's the null hypothesis. Sometimes this is also called this one down here is called the alternative hypothesis, not just H1. And so the alternative means that this is how related to this. I heard the word inverse. As a math guy, I hesitate to use the word inverse because that actually has a mathematical meaning. So use a word that starts with, I think Alex, you just mouthed it. It's the opposite of the research. So the research hypothesis in words. Oh, did you? I'm sorry, I didn't hear that. I'm sorry. Yeah, I saw Alex's mouth moving and I saw the word opposite. I didn't hear you. I'm going deaf at my old age. So here's the deal. This says, in words, the vaccine is working. What does this say in words? In words. The vaccine is working? This is an Alan question. The vaccine is not working! What does the vaccine not working mean?
Shouldn't it be equal to or greater than 12?
Say that again, Austin, nice and loud.
Equal to or greater than 12.
So, the opposite of less than would be either it's equal to, or it's in the wrong place, equal to or greater than 12%, correct?
Yeah.
That's the opposite, because there's two ways this vaccine cannot work. I give you a shot, and absolutely nothing happens. I'm basically injecting saline into your body, which will have no effect on flu rates whatsoever unless some kind of placebo effect kicks in. Or, unfortunately, what else could happen if I've done this vaccine wrong? You could get sick. You could get sick at a higher rate. So in other words, looking back to our curve, yes? If the vaccine does not work, and if it doesn't work by having no effect, you're probably going to land somewhere in here, likelihood-wise. If it doesn't work because it makes you sicker, where are you going to land? Somewhere over here, like where my head is, essentially. This is bad, obviously, from a vaccine standpoint. So that's why you put the opposite here, and you put what you're testing here. Because what you're going to do is, you know a lot about this curve already, yeah? You know a lot about this curve. You know that people for years have tested, and they've gotten sick at 12%. Roughly 1 in 8 people have gotten the flu during the season in this population. So you know something about this curve. You're trying to see if your data lives on this curve. Do you want, as a researcher, do you want your data to live on this curve? As a researcher? No. If your data lives on this curve, then your vaccine doesn't work. Your vaccine's no better than just being out in general population and take a deep breath. But if you can show your data lands down there significantly, metric down there, then we got something to talk about, yes? Then we got something to talk about. Statistically significantly, of course. Alright? Let's take 5. We're at 9. Let's take 5, yes? Shake out, this isn't yawning. And I think the heater's on in this room, which is beyond me.